All right, we're going to do another example of solving a system that has 3 variables in it. All right, these problems are, they have quite a few steps. So it's going to be super important that you stay organized. If you don't stay organized, you're going to get lost. All right, so first thing I'm going to do is I'm going to label this equation A. First equation A. Second one is equation B. Third one is equation C. All right, that way you'll always know what equation I'm working with. All right, here's our general strategy. Remember what we were talking about in our last video. In order to solve for a variable, right, we're going to try to solve for x, y, and z, but we need to do that one at a time. And in order to solve for x, let's say, we really need to have an equation that just has x's in it. Right? I can't really solve this equation here for x because I have a y and a z in it. So what I'm going to be doing is using elimination to eliminate variables so that I just have an equation with x's in it. All right, so let's see what kind of elimination would be easy. Well, here's one thing I see. I see that in equation A I have negative y, and in equation B I've got positive y. So you know what? It would be really easy to do an elimination with equation A and equation B. All right, so that's what I'm going to do. All right, let's do that down here. Let's rewrite equation A, and I'm going to rewrite equation B down here. So equation A says 4x minus y plus 3z is equal to negative 5. And equation B says 2x plus y plus z is equal to 1. And let's see what happens when I add these two together. All right, I'm going to get 6x, negative y plus y is plus 0, and then 3z plus z, that's 4z, equals negative 4. Right, and let's simplify this. This is the same thing as saying 6x plus 4z is equal to negative 4. Alright, so what happened? Basically, I used equation A and B, did elimination, and my y's were eliminated. So now I have an equation that just has 2 variables in it. Right? Again, that's not enough to solve for x, because I still have this z here. But that's getting better. Alright, that's getting better. Right, eventually we want to get an equation that just has either x or z in it. Right? I'm going to call this equation that I just worked with, this is going to be equation D. Okay, and we're going to use that equation later on. Alright, so let's think for a second. If I was working with equation D and I wanted to solve for x, what would need to happen? Well, I would need to be able to eliminate z. Right? In order to do that, I would need another equation that just has 2 variables in it. Right? It's not going to work to use it with one of these 3 equations because those have 3 variables. So what I'm going to try to do now is I'm going to try to do elimination again with 2 equations from the beginning and try to get another equation that looks like D that only has an x variable and a z variable, right? That has the y variable eliminated. Okay, so let's do that. Alright, let's see what equations would work. Alright, again, I eliminated y the first time, so I want to eliminate y the second time. Alright, I'm going to go ahead and use equations B and equation C. Alright, let me rewrite those down here. You'll see why in a second. Alright, you can really use whichever 2 equations you want, but I'm going to use B and C, and you'll see why in a second. Right? Equation B was this, 2x plus y plus z equals 1. Equation C is 5x minus 3y plus 2z equals negative 1. Alright, and what I'm going to do is try to eliminate y's in these equations. There's a negative 3 here, so it's going to be really easy to multiply equation B by 3 so that my y's can be eliminated. Right, so here's what I'm going to do. I'm going to multiply equation B by 3. Okay. Alright, so let's see what that would give me. That's going to give me 6x plus 3y plus 3z is equal to 3. And then equation C is 5x minus 3y plus 2z is equal to negative 1. Alright, so now let's add these 2 together. What do we get? We have 11x, and my y's are eliminated, plus 5z is equal to 2. Right? And now we have another equation. 11x plus 5z equals 2. Let's call this equation E. Right? And why is that good? Right? Because I have an equation D that has just two variables in it, and I have an equation E that just has two variables in it. Right? And why is that helpful? Because now what I'm going to do is I'm going to do elimination again. I'm going to use equations D and equations E. All right, let me rewrite those over here. Equation D was this: 6x plus 4z is equal to negative 4. And equation E was this: 11x plus 5z is equal to 2. Right? So this problem here is a lot easier to work with. Why? Because I don't have any more y's. I only have two variables. Right? So just to pause real quick. What was our strategy again? We started with three equations that had three variables. Right? That's too many variables to work with. So we're going to try to eliminate variables one at a time. Right? And I created equation D that did not have a y variable. So then, after that, I had to go back, create another equation, equation E, that doesn't have a y variable. Right? Now I've got equations D and E. These are easy to work with. Right? So let's solve for either x or y, x or z. And I think I'm going to solve for x. So to do that, I need to eliminate the z's. So let's see, what can I do? I'm going to multiply equation D by negative 5. And I'm going to multiply equation E by 4. Why is that going to help, right? Because negative 5 times 4z, this is going to be negative 20z. And then here, 4 times 5z, that's going to be positive 20z. Okay, so let's add these, or let's do the multiplication. We've got negative 30x minus 20z is equal to 20. And then on the bottom, the second equation, we're going to get 44x plus 20z is equal to 8. If I add these together, let's see what we get. We're going to get positive 14x. The z's are eliminated, is equal to 28. Right? And if I divide both sides by 14, I get the x value of 2. Right? So after all that work, I finally solved for one of my variables. Right? I got an x value of 2. Right? So now the hard part is over. Now that I figured out that x is 2, it should be easy to figure out what y and z are. Right? I just need to do a substitution and find out my y and z value. Right? So let's see, where should I substitute this? Where should I substitute this x equals 2? Well, what I really need to do is substitute this into one of the equations that only has two variables in it. So that would be either equation D or E. Right? So let's go ahead and do that. Right, I'm going to do that in equation D. Equation D says 6x plus 4z equals negative 4. So this would be 6 times my x value of 2 plus 4z equals negative 4. That's 12 plus 4z equals negative 4. And then I'm going to subtract 12 from both sides. So we have 4z is equal to negative 16. And then if I divide both sides by 4, I get my z value is equal to negative 4. Alright, so I have two variables solved for. I've got my x and I have my z. Lastly, how do I find my y value? Well, I need to use substitution with both my x and my z. And I'm going to plug that into one of my equations that has three variables, right? That way I'll be able to solve for my y. Let's do that with how about equation B? Equation B is 2x plus y plus z equals 1. Alright, so this is going to be 2 times my x value, which was 2, plus y plus my z value, which was negative 4, equals 1. This is 4 plus y minus 4 equals 1. That simplifies to be y is equal to 1. And there we have it. we have solved for my x, the y, and the z. Right, the final answer was x is 2, my y value is 1, and my z value is -4. Right, it was a long process. Right, but if you stay organized and show your work, it's not that hard.